Here I stand, atoms with consciousness, matter with curiosity, a universe of atoms, an atom in the universe.
The Interplanetary Podcast, the exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
So, Matt, that was your man, like Richard Feynman, yeah? Big up.
I've just finished listening on Audible to the classic Richard Feynman autobiography books.
What an absolute ledge.
So good. The section on the space shuttle, Jamie, is absolutely unreal. I just love the fact that he joins a committee with Neil Armstrong and Sally Ride and people like that. And
it's pretty strong, isn't it?
He's totally unimpressed by them. He's totally, yeah. And then there's that moon guy, Neil Armstrong, and I didn't even know who Sally Ride was. And it's just like, God. Wow. Literally doesn't give a monkeys. He's like, I just love the fact that the authority to him just means absolutely nothing.
Yeah.
But it's incredible just how out of hand the management had got it at the space shuttle, that it was just so dangerous and they just weren't admitting it. It's just incredible.
Insaniac.
Really, really good read. Jamie, before we go on, we have to do our shout out at the top of the show to the legends, the aces that are Justin Roberts and Justin Young.
The double Justins.
The double Justins, who this week paid for my trip to Hoxton to debate a flat earther on Lad Bible.
No way, you didn't.
I certainly did. Jamie, I don't know how they're going to edit it, but I didn't come away feeling as though I'd done my best job. So,
we still love you, however it comes out.
Well, let's hope. I came across with something sensible to say. I've had a brilliant idea, by the way, for us to do a little YouTube video about Flat Earth.
That way we can edit it ourselves.
We need to do it before this one comes out, so I can at least put this as a response.
As a reply, yeah.
Also, don't forget, Jamie, on the 5th of March, you can come to near St Paul's in London to the spacetalks.biz space conference.
Oh, yes.
Yes. So I'll be chairing a talk called "Workers of the Outer Space Unite."
Oh my goodness!
Bridging the gap between government, R&D, and manufacturing.
Well, it's a beautiful thing.
I'll be chairing that talk, and come and give me some support, Spodcats. That would be very nice.
I will actually be in France that day, so you're going to have to fly alone, Matt.
Ah, ouais, boeuf.
Yeah, oui. Matt, you know what I'd like to speak about?
I reckon I do.
If I said to you 30 years ago today, what would you say to me?
Well, I know that Carl Sagan is very much central to our love of space, isn't he?
Papa Sags, yeah.
Absolutely. And yes, today, as we do this, Jamie, it is Friday, the 14th of February.
Happy Valentine's Day, everybody. Did you get a card? Did you get a kiss? If you didn't, it doesn't matter, because you know what? We still love you.
Yeah, we still love you. This is our Valentine's to all you listeners out there.
Even if literally no one loves you, we do.
We do, absolutely.
Yeah.
Pale blue dot, Jamie.
Oh my God.
The famous pale blue dot. The picture that Voyager 1 space probe took 30 years ago today, when it was about 3.7 billion miles away.
Insane.
It was taking family portraits of the entire solar system. So Carl Sagan sort of noticed that if you turn the camera around as Voyager was leaving the solar system, it should be able to take a picture of all the planets.
Yeah.
And so they could all just have a little family portrait. And I think what an insight Carl Sagan has, that real popular touch, doesn't he? That he knows what's important, and that really is important.
Exactly.
So yeah, it wasn't just like he was writing about the pale blue dot. It was his idea to actually take the photo, and it's that series of photos is the very last photos Voyager 1 took, because they had to power down the camera, so all the other instruments, they're still working and still beaming bits back. could actually carry on working and sending data back as it travelled in interstellar space.
Not a bad last photo to take, is it?
No. Do you know why the Earth looks like a pale blue dot?
Well, I assume it has to do with our atmosphere and the sun.
Raleigh scattering of sunlight in the atmosphere that makes the Earth look blue and makes the sky look blue, but which is very unusual, of course, because a lot of this is caused because there's loads of oxygen in the atmosphere, and of course that is down to the fact that there's life, photosynthetic life.
Absolutely, yeah. Thank you, plants and trees. Yeah,
Thank you, plants that make us a nice blue planet. The oceans they contribute, but not as much as the atmosphere. But the clouds, the white clouds, make it a pale blue rather than a sort of dark blue dot floating in a moat of dust.
What colour would the atmosphere be if we didn't have any plant life or trees at all?
Ooh.
Would it
Well, I think
still
it'd
be
be-
blue?
Well, I guess it depends what chemicals are in the atmosphere.
Yeah.
I mean, like take Titan, that's orange because the atmosphere is so thick and doesn't have this oxygen that allows this Rayleigh scattering to occur. So it could be orange if the atmosphere was a bit like Titan, or
Oh,
it could
quite
just be
like orange.
Yeah, it could be the color of whatever the ground is. If it's something like the moon without an atmosphere, or Venus, I think is sort of fairly white, isn't it? It's just cloud covered and you can't see at all.
It's a beautiful thing.
Scattering. Yeah, the Earth is the prettiest of all the planets in the solar system. I know Saturn likes to show off with its rings, but it's got nothing on the pale blue dot.
No,
the blue marble.
What has?
But I think it's worth reading just a little bit of the quote, Jamie, with the
Should we
bit
do
that
it?
everyone loves. Do it.
Everyone you love, everyone you know, everyone you've ever heard of, every human being that ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilizations, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam.
It's beautiful, isn't it? What a legend.
There we go. Hot bang.
But bang.
On a mote of dust suspended in a sunbeam.
I think yours is better.
No, I thought I liked your impression actually.
Oh, thanks.
Jamie. I thought it was nice and subtle. It was really good.
We'll see how our listeners score us out of 10. So what's going on with NASA at the moment, Matt?
So NASA have just announced 4 more programs for their Discovery program.
Yeah, they have.
They have, and it seems like Venus is taking a bit of a little bit more interest. So yes, they've just been. It's not choosing missions that are going to happen, but missions that are basically they're saying go away and beef these things up. Here's $3 million each to go and do feasibility studies, and then we shall start looking at selecting the mission.
It's a beautiful
this
thing,
is
yeah.
what Thomas Zurbuchen said. He said, "These selected missions have the potential to transform our understanding of some of the solar system's most active and complex worlds." Exploring any one of these celestial bodies will help unlock the secrets of how it and others like it came to be in the cosmos.
Get to the chopper.
I don't know why I chose Schwarzenegger for Zurbuchen, but you know,
But
it's good.
I enjoyed it.
But
Yeah.
it's all right. Yeah, it wasn't quite Schwarzenegger. It was another kind of Austrian. Maybe I think Zurbuchen's Austrian. I need to look it up.
There we go. We do.
Do you want to know what the names of these and a rough description of each of these 4 are?
yes.
And we've Trident, of course. If you go back to podcast 135, We mentioned Trident, and it's this is a mission to go to Triton, the surprisingly active moon of Neptune.
Oh, yes, I'm interested. Okay.
So yes, that might the mission there I think would be extremely exciting.
So this would be to understand pathways to habitable worlds at a tremendous distance from the sun.
Yes, in other words, can we expand the Goldilocks zone out to ludicrous distances? Well, if you have life on Triton, would just be insane.
I think it's not going to have life on it.
Jamie, the two Venus ones.
Yeah.
And here's a corker of a acronym for you, Jamie. I know how you love them.
Oh, God.
Venus emissivity, radio science, INSAR, topography and spectroscopy.
Easy
or
for you
Veritas.
to say. Blimey. Okay.
Veritas sounds like an awful companies that people over the age of 65 might use for something.
Yeah.
I don't know.
Over 65 holidays.
Come on, a Veritas holiday.
Or maybe some hemorrhoid cream for your bottom.
Ooh, yeah. So
Apply
yes,
Veritas liberally on the affected area.
So that's going to be using one of these synthetic aperture radars that we hear so much about these days, and it's going to map Venus' surface, the surface of Venus.
Oh, quality.
To try and work out why it veered away from Earth's history and became a hot hell.
Why does that make me think of your old band Broadsword? That would definitely be on a Broadsword album, wouldn't it?
Oh yes,
This one's hot hell.
Well, Love Songs of the Planets. When I do Venus, I should imagine it will be quite heavy metal. That particular song.
It has to be. Yeah,
has to be. Da Vinci Plus, the Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging Plus.
Like it.
Yeah. And that's going to analyse, as it probably is, the clue is in the title, analyse Venus's atmosphere to see why it became a living hot hell.
Well, do you want to know my favourite, Matt?
Yeah.
Ivo, Matt, would explore Jupiter's moon Io to learn how tidal forces shape planetary bodies.
Io's that like ridiculously volcanic body in the solar system that just looks like it looks like a really nice sweet somehow. But yes, I'm sure it wouldn't be if you tried to pop it
I used to like it when Freddie Mercury used to sing about Io.
Did he?
Io!
Under the influence of Brian May.
This is it. Everyone thought they were just singing random things back, but wasn't.
Well, the planet Mercury was named after him.
Yeah. Good.
Jamie,
yeah.
We did say that we were going to talk about the launch of ESA's Solar Orbiter.
Oh,
Solo. I mean, that's one of the coolest names ever, isn't it? So
it has
being
to be.
named after a Star Wars character is pretty cool. Exactly. Solo or Sol-O.
Do you say Han or Han?
Han Solo.
I'd like it to be Han.
But it's Han, is it?
It's probably Han. I don't know. Any Star Wars geeks, can you tell us? Is it Han?
I like Han Solo.
Or
if
Han.
I was as a kid, up until maybe 3 years ago, I would have said Han Solo. But
I think everyone this side of the pond says Han Solo, yeah. But are we saying it wrong, Americans?
Who knows? Matt, I don't think this side of the pond, presumably in Germany, they say Han.
Han Solo.
Or Austria, they say Han Solo.
I love you. Ich liebe dich. I know. So there we go. Bit of German for you. Didn't know that I knew German, did you?
Anyway, Jamie, we need to get back to Solar Orbiter.
Let's focus, please.
Let's focus, Jamie. Yes, Solo. Completely the start of the golden age of solar astronomy, as we said a few weeks ago, because it's going up on the tail of this Parker Solar Probe, the NASA solar probe, and it's also joining these very, very large ground-based solar scopes as well. And we're just going to start seeing the sun in extraordinary detail soon. And I can't wait. I literally can't wait. The science for Solar Orbiter, SOLO, starts in about November 21.
Nice.
So we've got a year and a half to wait until it starts actually
not too bad
pumping out data, and it's planned to last about 7 years, but it'll almost certainly be extended for a long time after that. So the main objectives of the mission
is going to answer these questions, Matt. Are you ready?
Mm-hmm.
How and where do the solar wind, plasma, and magnetic field originate in the corona?
Mm-hmm.
Number
Pretty
one.
Important. Mm-hmm.
How do solar transients drive heliospheric variability?
Mm-hmm.
How do solar eruptions produce energetic particle radiation that fills the heliosphere?
Mm-hmm.
And finally, how does the solar dynamo work and drive connections between the sun and the heliosphere?
Pretty important stuff, Jamie.
Kinda.
There's loads of stuff we just don't understand about the sun. So this is going to be unprecedented resolution at wavelengths that cover visible, radio, extreme ultraviolet and X-rays. And it's going to form a lot of these in a very interesting orbit. So it gets its closest approach is going to be 60 solar radii, which is at 42 million kilometers from the surface of the sun, which is actually inside Mercury's orbit, but nowhere near as close as the Parker Solar Probe gets. That gets 9.9 solar radiuses away.
Yeah, that
So
is
that's
nuts.
like gets proper close, but this is pretty close. So at its closest approach, it's getting 13 times the radiation that you would do from, say, on the International Space Station,
Yeah.
and the temperatures get to about 520 degrees C. So you could completely burn a pizza at that temperature.
It would be hot.
It would be hot. So as Pierre Oliver, the solar orbiter safety engineer, said, he said, the main body of the spacecraft discovered and a multi-layered 3.1 meter by 2.4 meter each shield.
Okay.
Yeah, that's what he says. And
Cheers,
this
Pierre.
this is really cool, Jamie. I absolutely love this. So the spacecraft and the instruments of this heat shield is made from this sandwich structure, multi-layered insulation, but it's coated with this thing called solar black.
Oh.
And the interesting thing about solar black is this is a pigment that was used in prehistoric times to do cave paintings. And that's why we see the cave paintings, because they happen to choose this material that's unbelievably resilient.
Shut the front door.
Shut the front door. So it's basically burnt bones, basically, black calcium phosphate from burnt bone charcoal.
It does sound pretty resilient.
Yeah, and how they get it onto the titanium structure is really interesting as well. So, with things like titanium and aluminium and things like that, one of the things that makes them weather resistant is that they actually form an oxide on their surface that's really resilient to corrosion. So they kind of almost protect themselves, those types of metals. And if you blast this oxide off the surface of your titanium with like grit, if you dope the grit with this solar black, then the solar black takes the place of the oxide and is bonded onto the metal extremely well. You have this really, really well coated, very, very hard to get off ancient pigment, super black pigment on the titanium. And do you know where they do this?
Go on.
They do this at the University College Dublin campus.
Oh, no way.
A company called NBO.
I love that.
And do you want to hear my offensive John O'Donoghue impression?
Oh, yeah, do it.
Yeah, here we go. So he goes, we found that the solar black works well as a toy layer, foundation on metal, allowing us to place another layer on top. In this case, a carefully tailored conducted white ceramic. So there's this other material, solar white, which is a ceramic, Jamie, that protects the instruments as well.
That was good. That was a good accent too, Matt. My ancestors from County Cork, I think they'd be impressed.
Would they? I don't know. It's always a bit dodgy as an Englishman doing Irish accents. I think
it's all right. It's okay.
It's all, but I love the Irish, don't you?
I love them.
I love you, Jamie. And
yeah, you do.
You got your Irish heritage.
Got my quarter Irish in me. Yeah.
Yeah, I love the Irish, and I love everyone, Jamie. I love all of mankind.
Everyone.
I'm a bit like Carl Sagan.
One love.
So yes, this orbit, Jamie, is a resonant orbit around the sun, and it resonates with Venus. So every 3 times it goes round the sun, it gets a little nudge from Venus that actually changes the inclination. So it can actually start getting higher up towards the poles of the sun. So by 2030, it should be about 30 degrees up, which means it can actually start looking down at the poles and give us some information about that. But not only that, the orbit also means it's coming in at a velocity that's similar to the angular velocity of the sun, so it can stay over the top of a region of the sun for a long time and therefore do a really careful study of the sun at that point.
Oh, I like it.
Which is very clever. The people that design these orbits, they are clever, aren't they?
They are really clever.
They are really clever.
Bright folks.
There's a bunch of instruments, Jamie. 10 instruments on this bad boy.
All right.
I go through them all, but they're kind of there's kind of 2 main banks: the heliospheric in situ instruments and the solar remote sensing instruments.
Yeah, there's a lot of them. We don't have time for it. But
no, but I mentioned the two that are. Let's mention the 2 that are built in, mainly built in Britain. The British are kind of like the United
you do
Kingdom.
the first one.
Solar Wind Plasma Analyzer, the SWA, the SWA.
Come on.
And that's a suite of sensors that measure the ion and electron bulk properties, density, velocity, and temperature of the solar wind. So that's going to be measuring the solar wind, and that's I think the UK are the project managers on that one. And what's the other UK instrument on there?
Well,
Jamie?
what about MAG? The magnetometer. Yeah?
Yes.
It will provide in situ measurements of the heliospheric magnetic field with high precision.
Of course, it'll be high precision. It's built in the UK, Jamie.
#UK.
So, yeah, lots and lots of countries involved: Spain, Italy, France, Germany, Belgium, etc., etc., etc. And even NASA have.
It was almost as if we were still part of Europe.
Well, we're part of the European Space Agency, Jamie, and that will not change.
Exactly.
Just for people who are confused about that, the European Space Agency has nothing really to do with the European Union, and therefore we are still a major contributor to the European Space Agency. And actually, it's a really good model, I think, that you can stay in European clubs. We haven't finished being European just because we're not in some economic club.
Exactly. Whether you like it or not, Matt, I'm a European, and I'm going to stay a European until my bones turn black and cavemen use it to paint on walls.
I'm actually a child of the world, Jamie. I have as much affinity with Carl Sagan as I do
We are the world.
with Arnold Schwarzenegger.
We are the people. Okay.
So, yes, Solo Orbiter Heliospheric Imager, Jamie, comes from the United States. So NASA, as well as doing the launch for the Europeans on this one, also the Americans have supplied this instrument as well that measures the quasi-steady flow and transient disturbances in the solar wind.
Matt, talking about steady flow, we got quite a few responses to our dark matter special last week.
We did, mainly people's whose brains just melted and flooded on the floor. Not surprisingly, because it was.
Yeah.
And just to reiterate, we are talking about highly speculative things here. I think that we have to put a pin in, say, Occam's razor would suggest that these aren't necessarily going to be how it all pans out. However,
correct.
It's interesting to know that there are these theories out there. And another theory came our way again from a South Coast university, this time Plymouth. It's quite a famous one. I hadn't actually really given it much thought before, but someone said that Professor McCulloch himself hoped that we would feature this on this week's show. So I can't really resist that, can I?
Can't resist that.
I can't resist it. So Professor McCulloch, who works at Plymouth University, like I said, another South Coast university, has invented a theory called QI, or quantized inertia theory. And basically, one of our listeners wrote in and said that dark matter can be explained by information theory in another way, and that's this quantized inertia theory. I don't actually know what the information derivation is, but I do know what this one derivation that I shall tell you about. But basically, QI is like a bit like one of these modified theories of gravity. But it seems that the upside of it is that the modified gravity normally falls apart when you look at the bullet cluster picture. It's like the bullet cluster pictures really suggests that dark matter is an actual thing rather than a sort of that you can explain it by sort of having variable gravity depending on conditions. But this one seems to get round that. So do you want a quick primer on what quantized inertia is?
Let's do it.
Let's do it. So first of all, we've got to talk about this thing called the Unruh effect. Have you ever heard of this?
I can't say I have.
No, well, I have, because we may have mentioned it when we talked about Hawking radiation.
It rings a bell. Yeah.
Stephen Fulling mentioned it in 1973, Paul Davis in 75, and Unruh in 76. So sometimes it's known as the Fulling-Davis Unruh effect. But Unruh effect, because obviously W.G. Unruh must have fleshed out the theory enough to have his name kind of put on it. But
yes.
So remember, Jamie, where you're sitting right now is literally at the center of your own visible universe.
Very true.
Right? And so your universe has an event horizon, a bit like a black hole has an event horizon. You simply cannot know what's happening on the other side of that bubble, because the light from the other side of that event horizon can never get to you. So no information can ever get to you. And that's that, right? Now, there are these things called virtual particles, and space just can't be a vacuum, and these virtual particles appear as positive and negative pairs. They borrow some energy from the quantum vacuum, and then they annihilate each other pretty much straight away, repaying that debt back to the universe pretty quickly, like really good debtors. They're good guys, these virtual particles. They pay off their debts very quickly. The universe has very, very harsh borrowing terms. A bit like my bank.
Big APRs.
Yeah, so really, really nasty APRs. But Stephen Hawking's had an amazing... what he is famous for, Stephen Hawking, is his amazing insight that if you have these virtual pairs of particles popping in and out of existence, well, what happens if this happens right on the edge of a black hole event horizon, and one falls in before they have a chance to annihilate, and then the other one escapes? And what happens there is the universe still wants its money back, so the black hole ends up being the generous middleman and paying back the universe this energy. But as a result, the black hole starts to get smaller and smaller and smaller, the more energy it's paying off for these naughty virtual particles that are running off without paying the energy back. So, yeah. And right at the end of a black hole's life, it dies extremely angry in a flash of radiation, Hawking radiation, as it's realised it's been duped by these naughty Norman virtual particles. So they've buggered off with all this energy. But yes. So think about your event horizon. Remember, you've got an event horizon as well. You've got this event horizon where you cannot see beyond it. What happens if these virtual particles are doing the same thing there? Yeah. So in your frame of reference, there'll be a type of radiation coming at you because, yes, another region of the universe that you can't see has just paid your debt of energy from these virtual particles on that event horizon. And so, yes, you are now being bombarded by Unruh radiation.
Oh, it doesn't feel good.
Yeah, so not a bit like Hawking radiation, except this radiation, instead of coming off the event horizon of a black hole, is coming off your event horizon of the visible universe, the boundary of which you have. This is pretty accepted by loads of physicists, And it's an idea that some have even claimed to have seen it, this Unruh radiation. Igor Smolyanov,
No
in
way.
his photoluminescence from a gold nanotip in an accelerated reference frame. He's basically wiggling a needle around and seeing some light. Doesn't seem to have been repeated, that experiment, though, so it may be a load of rubbish. But it's fairly accepted, this Unruh radiation. But enter the Casimir effect. So here's another thing that was a phenomenon that was predicted in 1948 by Casimir. And basically, if you imagine virtual particles, remember their wave particle duality. These are waves, so only certain wavelengths can exist in an area that's big enough for their wave to actually fit in. So if you have two uncharged plates very, very close together, you can only have certain particles springing into existence and then springing back out again. And so there's only a certain amount of virtual particles that can appear within that tiny space. And on the other side, you've got the rest of the universe, so you can have as many particles as you like. So there's a misbalance. And so more virtual particles are smashing on the outside of these plates than on the inside, creating a pressure pushing the plates together. And that can be measured, and it's about an atmosphere of pressure if the plates are about an atom apart from one another. So it's significant and measurable.
Pressure.
So let's go back to you in your bubble with the event horizon.
Yeah.
You start accelerating in a direction.
Yeah, I do.
So you start accelerating off in a direction. Now your bubble is changing, right? Now you can see beyond the horizon in front of you, and the horizon behind you is shrinking away. And these are known as Rindler horizons, and now you're in Rindler space. So the Unruh radiation coming from the front, you're going to have a bit like this Casimir effect on a Hubble scale. You're going to have more Unruh radiation in front of you than behind. So this Unruh radiation is going to be exerting pressure on you, and this pressure is going to be impeding your acceleration, or you could call that inertia, if you will. So it actually explains inertia. And then let's apply this to the stars that are going around galaxies. Now, what we're saying is that stars are moving too fast around galaxies, and therefore the galaxies would just spin apart.
That's
but
right.
if you apply this Unruh radiation, this Unruh pressure, this quantized inertia to these stars, it counteracts that force, and so no dark matter is required.
Oh, my head hurts again.
And so that's the proof for that one. Now, loads of scientists, Jamie, are calling this pseudoscience. And I actually think that's a little bit unfair, because dark matter itself, after all, is like an ad hoc piece of reasoning, right? It's a theory in response to observations that falsify the main theory of gravity. So at worst, it's a hypothesis which adds no empirical content, and therefore it's not really falsifiable. Dark matter, in some ways, and some people would argue, isn't a great theory itself. But I think the reason why this is so controversial is that if you believe this, you have to abandon, a lot of what Einstein said and the lambda CDM model. A lot of evidence suggests that is right. It's more to do with the fact that Professor McCulloch, I think, started linking this quantized inertia to things like EM drive. And I think really we're back to Occam's razor. There's loads and loads of things that we should be looking at, more mundane explanations for things that need to be ruled out first. And like a classic one was that he linked it to the Pioneer spacecraft. So the Pioneer spacecraft was getting some weird inertia, and they didn't know what it was. And McCulloch said, well, it's this. And then it turned out, no, it's the thermal recall of the power supply. So, and it's the same with the EM drive. Yes, there was a thrust, but there's loads of things that need ruling out first. But, one of my favourite Sherlock Holmes quotes, Jamie?
Go on then.
When you have eliminated the impossible, whatever remains, however improbable, must be the truth.
Oh, that's good.
So there you go. It's highly unlikely, but I don't think it's pseudoscience. I think that's really unfair, and I don't think it's ruled out. But it's on the fringe there. But one day we might be talking to Professor McCulloch, and he might be as famous as Einstein.
Well, Matt, do you know who else I'm going to make famous?
Who?
A list of our Skylon patrons.
Ah, yes, do it, Jamie.
Bob Hodges.
Legend.
John Banak.
Legend.
Julio Aprea.
No words.
Karel Sim.
Legend.
Sven Newhouse.
Legend.
Darren Fuchs.
Legende.
Patrick Hayward.
Legendimus.
Mark Schwern.
Legendissimus.
Stas Shusha.
Legendissimusama.
Christopher Andreasen.
Legendissimusissimus.
Rob Annabelle.
Mega legend.
Auden Vala.
Legend.
Anthony Peggs.
Legend.
And last but not least,
Definitely
Matt
not
Gilliland.
least. Awesome. What an absolute bunch of heroes they are. And
What a motley crew of ledges.
And unfortunately, they've been really, really active on our Discord channel. And so can you if you join us on the interplanetary.org.uk and go to our Patreon, patreon.com/interplanetary. Come and join us.
And join us.
Join in the conversation. We haven't got time to talk about some of the subjects that came up on the Discord. Not even the unbelievably underwhelming design for the new spaceport in Scotland, which basically must have taken all of 5 seconds on SketchUp to do. But anyway, we'll get to that next week. Jamie, it's been absolutely awesome speaking to you on this very, very busy week. I wish you lots of luck in LA and France.
Oh,
and let's
you,
hopefully
mate.
we can hook up and do this. I have an unbelievably exciting guest on Tuesday, but I don't want to jinx it. But
oh my God, let's not say anything.
It's one of the world's most famous astrophysicists. So next week's going to be a corker.
Oh my God, I can't wait. All right, everyone, have a good weekend. I'm off to pump out some data.
Excellent. You pump it out. You pump out some data and make sure that information doesn't have too much mass.
I'll try not to.
Is that why I'm getting heavier, Jamie, on the scales?
It's all the information in your head.
It's not all those biscuits I'm eating late at night.
That's why I stay svelte,
all the knowledge
because of the
I'm
lack
learning.
of knowledge.
Actually, I do weigh considerably more than you, so that might be it. I look just as slim. I look just as slim as snake hips. Jamie, let's go.
Let's go.
Bye-bye, Spud Cats!
See you soon, bye.
Bye.